Hello, beautiful people, and welcome. In this video, we're talking about geometric sequences. Now, previously in semester one, the first semester, you did arithmetic sequences. Geometric are similar, but the difference is that the pattern is different. Therefore, we have a different type of sequence. As always, disclaimer time, if I make a mistake, I'm human. Please let me know where the mistake occurs so that way I may learn from my mistakes and you may learn from it as well. Alrighty, beautiful people, let's go ahead and get started. So what is the pattern of a geometric sequence? Well, let's go back to what is a sequence. So a sequence is an ordered list of numbers. It doesn't matter what that order is. As long as you list some numbers, they are in a particular order. The geometric part tells you what the pattern is. So these numbers are listed in this specific pattern. So for example, an ordered list of numbers could be 1, 2, 3, 4, 5, etc. Right? That doesn't mean that order list is geometric. It just means that's an ordered list of numbers. It is a sequence. So for geometric, there is a pattern. And what that pattern is with multiplication. So it's a multiplicated pattern. Let me try to explain that in a better way. The pattern is from your left number to your right number, you're going to end up multiplying by something. And I'm going to call that my little r. Now, little r is a common ratio, and we'll just kind of tell you the definition in just a little bit. I want to focus a little bit more on the pattern. So what does that mean? The left number to the right number, you're going to multiply by r. For example, let's say I have a geometric sequence of 2, 4, 8, 16, etc. How do I know that this sequence is geometric? It's because it follows a pattern. How do we get from 2 to 4? Well, we can add 2, but we can also multiply by 2. The pattern has to be the same from all numbers. So from 2 to 4, 4 to 8, 8 to 16, and etc. The 3 dots that we have here, right here, the last, just means that the pattern continues. So how do we get from 2 to 4? Well, we multiply by 2. How do we get 4 to 8? We multiply by 2. How do we get 8 to 16? Multiply by 2. And if we wanted to know what the 1, 2, 3, 4, 5th number is, we would just continue the pattern and multiply by 2. Now, the pattern doesn't always have to be multiplied by 2. It just has to be multiplied by the common ratio. Now, what is a common ratio? Common ratio is, in other words, the pattern. What did you multiply by? Now, the easiest way to find what the common ratio is you're going to take your left number. Let's do our right number. It's going to be our right number divided by your left number, and that's equal to your common ratio. Common ratio has to be common. It has to be the same. Let me give you 2 examples. So let's do our 2, 4, 8, 16. And let's do our 2, 4, 6, 8. Again, we're trying to see if this is a geometric sequence. So what I would do is I would take my right number divided by my left number to see what my common ratio would be. In this case, I have, let's do it here. Let me actually keep it in blue. So I would have 4 divided by 2. So my right divided by my left, and that's 2. Now I have to check and make sure that my common ratio is common. I have to do that all over again. So now I'm going to do, this is my right, this is my left. So now I'm doing 8 over 4. 8 divided by 4 is 2. And then I'm doing one more time. I'm doing my right over my left. So now I'm doing 16 divided by 8. 16 divided by 8 is 2. So for this geometric sequence, my common ratio is 2. So R Little r is equal to 2. Now let's see example number 2. Now for example number 2, it starts out the same. So here's my right, here's my left. So I have 4 divided by 2. 4 divided by 2 is equal to 2. So far so good. Then I have, here's my right now, here's my left. So now I have 6 divided by 4. 6 divided by 4 is, I don't know, I think it's still a fraction. It's 3/2 or 1.5. I'm double checking my math here. How I got 3/2 is I divided by 2 top and bottom. So because this is 2 and this is not 2, these do not match. This is not common. And because it's not common, there is no common ratio. So this is not geometric. If you do not have a common ratio, that means the sequence, the list of numbers, is not geometric. There is no pattern to it. You will have to know a formula, so let me go ahead and write that formula out for you. The formula is this. We have a little n, so this is called a sub n, is equal to a sub 1 times r to the n minus 1 power. So the n minus 1 is the power. Notice that it's smaller and above. I'm going to highlight that for you so you know. So that's our formula. Now, what does a sub 1 mean? A sub 1, this right here, this guy right here, this means the number in the first position. For example, 2 is in the first position. It's just the first number that you see. So the little 1 here, let's see if I can find a quick highlighter. This 1 tells you that it's in the first position. Now, a sub n, this one here, it's the number in the, and I'm going to put this in quotations, n position. This is typically your unknown. So like if they tell you what is in the 27th position, so you would say n is 27. So this is your unknown. And I'm going to write typically. Sometimes they do give you, they tell you a sub n is this number. But a lot of times you don't know what a sub n is. You don't know what n is. So what is n? N is the position number. So let's do a quick example. And I'm going to give you a geometric sequence. So I am telling you this is a geometric sequence. Sometimes they'll do that in the directions, which is easier because then you know there a common ratio exists. So let's do a sequence of 6, negative 12, 24, dot, dot, dot. And I want to know, I want you to do a few things for me. Step number 1, I want you to find the common ratio, r. Then I would like for you to identify what a sub 1 is, a sub 2, and a sub 3. And then we'll write an equation. So again, how do we find r? You can also ask yourself that question. How did I get from my left number to my right number by multiplication? So here's my left number, here's my right number. How did I get from 6 to 12? Well, from 6 to 12, 6 times 2 is 12. However, do you notice that this is negative? So I have to multiply by negative. Now, here's my right, here's my left. I always have to double check all numbers. How did we get from 12 to 24? 12 to 24 is times 2 again. However, notice that my negative disappears. That means I do have to multiply by negative. So my R value is negative 2, my common ratio. Now, what is A sub 1, A sub 2, A sub 3? These are your position numbers. So A sub 1 is the number in the first position. A sub 2 is the number in the second position. A sub 3 is the number in the third position. So A sub 1 is the number in the first position. So A sub 1 is, let's look here. What is the first number that you see? Well, here is 6. Here is negative 12. Here's 24. So the first number is 6. The second number is 12. And the third number is 24. So what is the number in the first position? The number in the first position is 6. What is the number in the second position? The second number is negative 12. What is the number in the third position? The third number is 24. All right, let's do the equation now. I'm going to write the sequence one more time. So this is the sequence that we have. We had 6, comma, negative 12, comma, 24. The information that you said for number 1, you said R was negative 12. For number 2, we said A sub 1 is 6, A sub 2 is negative 12, and A sub 3 we said was 24. This is the information on this page. I just copied it down. All right, so now we want to write the equation. So how do we write the equation? Well, let's start with the formula. So the formula, again, I'm looking here in my notes. The formula is A little n is equal to A sub 1 times R to the n minus 1 power. So we're going to play a little keep, change game. So we're going to keep the A sub n. We're going to keep the n minus 1. Those do not change. Let's see if I can say that. That should say keep. Let's change this one too. We're going to keep both. Now what we're going to change is we're going to change your A sub 1 and you're going to change your R. So how would the formula look like? The formula is going to look like, we're going to keep A sub n, so we're going to copy it down. We're going to change A sub 1. We're going to times that by R, but we're going to change R, and we're going to keep my n minus 1. So I'm going to copy this down one more time just to let you guys know. So in this bubble, my A sub 1, my number that is in the first position. What number is in the first position? Well, we can look here at number 2 where we can just look at our sequence. The number in the first position, the first number that you see is 6. So I'm going to put 6 instead of A sub 1. Now, R is my common ratio. That's my pattern. That's my pattern. What do I multiply by each time? The number has to be the same in order to get my pattern. We said our pattern was being multiplied by negative 2. So that means once you change a sub 1 and r, that is your formula. That is your equation. And it's okay that you still have n in there. Don't worry about it. This is your equation. This is your answer for the equation. Now, what's really cool is we can use this equation now to solve for a different number. So I'm going to say use the equation to find the 24th term. What that means is I have 1, 2, 3, blah, 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 24 number in the 24th position. So if this is my first number, this is my second number, this is my third number, if I continue the pattern, what is in this number? What is in this place? We already know that in the first position we have 6, in the second position we have -12, in the third position we have 24. Now on something like this, because we want the 24th number and it's being multiplied, so it's going to be a little bit of a larger number, I do need you to use calculators. You won't be able to do this unless you do it by hand, and it's going to take a long time. So you need to use a calculator. So what we're going to do is we're going to take our equation. We're going to take a sub n is equal to 6 times -2 n minus 1. Because we want to know the 24th position, I'm going to go back to our notes. Remember, n is the position number. I want to know what the 24th position number is. So here is my n, so that's the position number, and here's another n here. So what you're going to do is you're going to replace n with the term number that you want to find, the position number. So I'm going to say a sub n, which is now 24, is equal to 6 times -2 to the 24 minus 1. So here's my n again, and here's my n minus 24 minus 1. So now we're almost done. Now you're going to solve. You're always going to keep this a sub 24 or a sub n, whatever it is. You don't have to solve it. You can't solve it. This is what you're trying to solve for. This is your unknown. You want this to be part of your answer. Now on this side, you're going to evaluate. So you're going to say 6 times -2, and this now you're going to say 24 minus 1 is 23. Then you're going to, in your calculator, evaluate what this number is. It's going to be big. You're going to put that into your calculator. And this is how I'm going to do it on my calculator. On my calculator, I'm going to do parenthesis -2. Now, depending on your calculator, you might have to do a caret, a symbol like this, and then 23. So in my calculator, I'm doing -2 caret 23, and it's going to give you a big number. That's okay. And this gives me -8388608. I still have my 6. And I still have my a sub 24. So now I'm going to multiply times 6, and I get -5033164 as my answer. So in the 24th position, so here, if we continue the pattern and continue it, the 24th number will be -5033164. So in the 24th position, I have this big number. All right, beautiful people, this wraps up this video on geometric sequences. I hope you enjoyed it, and I will see you in my next one.